Okay, I'm just going to go through the beginning of the blend space and point out a couple things. I think what we're doing today is pretty conceptual, but let's take a look at solubility. So we're talking about solutions, and solutions require a couple of things. One, that we have a homogeneous mixture of at least two substances. Homogeneous, again, means that it's evenly mixed. And the proportions of the substance are not fixed, which means we can have more or less proportions of solvent to solute. You can have salt water with a lot of salt or salt water with just a little bit of salt. It's still a solution. And it's also only going to be in one phase, one state of matter. The two components that make up our solution is our solvent, which is the substance that does the dissolving, and it's usually present in the largest amount. And the solute is the substance that is dissolved, that's broken up in the solvent. Solute can be solid, liquid, or gas. But when we have our solute dissolved in our solvent, we call the whole thing a solution. Solution is a solvent that dissolves a solute. We can have all kinds of different types of solutions. There can be gas, liquid, or even solid solutions. Air is an example of a solution where oxygen dissolves nitrogen gas. So that's a gas-gas solution. Soda water involves a gas dissolved in a liquid. Carbon dioxide gas is dissolved in water in a Coca-Cola or a Pepsi or a Dr. Pepper. Let's see. Liquid and liquid vinegar is acetic acid dissolved in water. Seawater is sodium chloride, which is salt dissolved in water. It's a solid in a liquid. Iodine tincture is iodine, solid iodine dissolved in alcohol. We can even have solid solutions. Dental amalgam involves mercury dissolved in silver. Steel involves carbon, solid carbon dissolved in iron. And all of these are solutions. Let me quickly just pull up the chat to make sure I'm not missing any chat. But let's keep going. Oh, there was a question in chat about the personal project presentations. No, you're not giving an hour-long presentation, but you'll be in a session that lasts an hour. So you'll have to attend an hour-long session. Your presentation will probably be about 5 minutes. And there will be maybe 10 or so other students all giving 3 to 5 minute presentations on their personal project. So your presentation is going to be quite short. You'll have to be quite quick. But you'll have to stay for the entire hour meeting because you're going to be, well, you're going to be the audience for your classmates. Okay, so next thing we want to talk about is solubility, which tells us of the maximum amount of solute that will dissolve in a given amount of solvent at a specific temperature and pressure. So solubility changes at different temperatures and pressures, which is why we have solubility curves. Usually we express solubility in grams of solute per 100 grams of solvent. But you have to be careful because sometimes solubility is expressed in grams of solute per grams of solution, which would be the solute plus the solvent. And it changes the math when we're dealing with the different units. We're not going to be doing much math today, but we will as we will do more in the next coming days. But just be careful about your units. Careful about your units. If you have solid solutes, in order to dissolve better, you want to stir your substance or grind your solute into smaller particles. If you have finer salt crystals, they'll dissolve faster. Also, if you heat up your substance, it will dissolve faster. If you have a gaseous solute, you want to increase the pressure to push more of that gas into your other gas or liquid or solid. You want to decrease the temperature of your gas so it's not moving as fast, so it can be captured more easily. Solubility curves are usually given with the x-axis as temperature and the y-axis as solute in grams per 100 grams of solvent. And the curve here, the actual line, tells us the saturation point of our solution at a given temperature. So at lower temperatures, if this is salt water, for example, at lower temperatures, we can hold less salt. At higher temperatures, we could hold more salt in our water. Everything below the curve can also exist. You can always have less salt than the maximum. We just call it an unsaturated solution. Everything above the curve is a supersaturated solution. You saw in the video what happens with supersaturated solution. Supersaturated solutions can exist, but they're unstable because we have more dissolved than is normally possible. And as we saw in the video, if we have a supersaturated solution, we can get crystals that form if we in our supersaturated solution, if anything disturbs it. So unsaturated means that we can dissolve more solute in our solvent. A saturated solution is when no more solute dissolves. If you're ever making salt water, you fill it up with salt, you warm it up, and you stir it. At a certain point, no matter how much you stir, there's gonna be some solid salt at the bottom. That's when you're saturated. If you're super saturated, you won't see that very often, but if you add any additional salt, you'll get crystals that form. Here's an example of a solubility curve and a quick question. So if a solution had 100 kilograms of solute dissolved in 80 degrees Celsius solvent, is it saturated? 100 kilograms of solute per 100 kilograms of solvent. So let's just look at the units on our graph. This is kilograms per 100 grams water. This is temperature. If we're at 80 degrees Celsius and we have 100 kilograms per 100 kilograms, we just got to find that on the graph. 80 degrees Celsius, 100 kilograms per 100 kilograms. It's below the line, so it is not saturated, which means we can add an additional, it looks like it's more than 25. It looks like we can add about 30 additional kilograms of water, 30 kilograms of solute per 100 kilograms of water. So in a 100 kilogram vat of water, we could add another 30 kilograms of that solute. Any questions about reading graph?
Okay, so here are a few practice problems on solubility and solubility curves. You want to use this graph on the right, which has a lot of different solubility curves, all combined together, to answer these 4 questions. Each different solubility curve is labeled with the substance that, with the salt that is being dissolved. And look on the side, our units are grams of that salt per 100 grams of water, and our X units are temperature. So please pause this video and try these problems. Okay, hopefully you got some answers to these. I'm going to go through them. A. At what temperature is the solubility of KClO3 20 grams per 100 grams water? Okay, so we know that we're working with KClO3, so let's find it. Here it is. It's this brown curve right here. And we want to find the temperature where the solubility, it's our Y variable, is 20 grams per 100 grams. So that's right here. So let's find where that intersects with our solubility curve. And it's right here. So that, what temperature is that? That looks like it's about maybe 54 degrees Celsius. So for A, it's going to be about 54 degrees Celsius. B, what is the solubility of sodium nitrate at 10 degrees Celsius? So let's find sodium nitrate. Here it is. Here I'm doing green. So at 10 degrees Celsius, what we're going to do is go to 10 degrees and then find our intersection with that curve. So it's all the way up here. And it intersects right at this point. So we can see that is 80 grams of salt per 100 grams of H2O. So our solubility is just 80 grams per 100 grams of water. Number C, or letter C. At 50 degrees C, 50 grams of KCl is dissolved in 100 grams of water. Is the solution saturated, unsaturated, or supersaturated? So first of all, it's KCl, and we have 50 grams per 100 grams, and it's 50 degrees. So let's look at 50 degrees on our x-axis, and 50 grams per 100 grams on our y-axis. That's right here, in dark blue. Label that C. Because that's at 50 degrees and 50 grams per 100 grams. And we want to know if it's saturated, supersaturated, or unsaturated. So saturated means it's going to be on the curve, on the solubility line, curve line. Unsaturated means it's going to be under the line, so somewhere down here underneath our KCl line. Supersaturated means over that blue line. And since it's over that blue line, it is supersaturated. Which means there's more dissolved solute than can normally occur. Letter D, at what temperature are the solubilities of KClO3 and NaCl the same? Okay, so if our solubilities are the same, then the graphs will intersect. So let's find the graph of NaCl. That's this light blue one. And KClO3, where's that? It's this brown one over here. So where does this light blue graph and the brown one intersect? Well, it's right here. I'm going to label that D. And at what temperature is that? Well, we just read the temperature value off our temperature axis. Looks like it's at about 82 degrees Celsius. 82 degrees Celsius. So just whenever you're using solubility curves, just make sure you're reading the values off the graph. It really is just a lot of graph reading. Your independent practice is on the hub. It is the solutions quiz. You should be able to find it in the folder for solutions 1. Make sure you get that completed today, which is Friday. Your flipped assignment is to complete the molarity Edpuzzle. That's all. Goodbye.